Graphical displays of data. An easy way to get a sense of the distribution of our data is to look at a picture of it. So we'll look at these different types of graphs that we could have and when they're appropriate. Pie charts are great for categorical or qualitative data. Here's our frequency distribution of cell phone operating systems. The pie chart divides the pie up by percentage. So quickly you can look at that pie chart and get a sense of the relative size of each of those operating systems overall. One limitation is if there's too many classes, the pie can get chopped up into too many pieces to where it's hard for the reader to tell which slice is which. But for a small number of classes, it works quite well. Another way of representing that same data would be in a bar chart, where the heights of the bars give us the frequency. Sometimes you see these bars going horizontal, doesn't really matter. If the bars are sorted in descending order, then that's called a Pareto chart. It's just a sorted bar chart. Now, as we move into quantitative data, here's a grouped frequency distribution and then a corresponding histogram. Similar to the bar chart, you're counting the frequency on the y-axis. But notice how all those bars touch each other? Unlike categories where as you move from one category to the next, there's no connection. For quantitative data, we're really moving along that x-axis just like we would in algebra. So there's sort of a continuum there. And to emphasize that, we'll put those bars right up against each other. Frequency polygon. Well, this is just like our bar chart, but instead of using bars, we place a dot and then connect the dots with a straight line. An ogive is a frequency polygon where instead of plotting the frequencies, we're plotting the cumulative frequency. So remember, cumulative frequency is a running total. So you'll always see that polygon either staying level or going up, since it is cumulative. A stem and leaf plot breaks the data up into the beginning part of the number and the ending part of the number, the beginning part being the stem and the ending part being the leaf. So here we have our miles driven to school data, and the stem has actually been the whole number part and the leaf is the decimal part. Notice that in each one of those stems, the leaves are in order. One advantage to this is for the reader, they can easily scan through to find the middle value. Also, the advantage to this over, say, a histogram is not only do you see how large each class is, you actually see the individual data values in that class. Lastly, notice I have a key here. Where you break that number into stem and leaf can vary depending on what kind of numbers you're dealing with. Say we were doing test grades where all the tests were whole numbers. Maybe the first digit, the tens column, would be our stem and the ones digit would be our leaf. So the key helps the reader see how we're breaking that number. And the key just uses an example number. So 2/1 means 2.1. A dot plot simply puts a dot for each data value along an x-axis. If there's repetition, we stack the dots. This data only had two values, 3.1 and 3.7, that repeated, so we only have those two dots on the second line. A line graph is usually used for a time series. What I mean by a time series is a measurement on a variable that's taken over and over again through time. The x-axis is a natural for representing time. This shows price performance for an investment fund. So we can see the price over time, typical of line graphs we see. So in looking at these different types of display, the first couple, pie charts, bar and Pareto charts, were great for qualitative stuff or categorical stuff, but the remaining ones are really more for quantitative variables.